Hi, I'm Tim Tyler, and this is a video about the Balkanisation of universality. To start by explaining what I mean, universality refers to the idea of a universal computer, an idea that was pioneered by Alonzo Church and Alan Turing in the 1930s. These guys. Church and Turing's key idea was that all computers are, in a sense, equivalent to each other. That once you've built what is known as a universal computer, you can use that to emulate any other type of computer that you care to imagine. That computers differ from each other mainly in terms of their total storage space and the speed with which they execute instructions. Turing went on to show not only that all computers are equivalent to each other in this sense, but that you can build a very simple computer that is universal. This type of computer is now known as a Turing machine, and it consisted of a read-write head and an infinite tape which could be used to read symbols from and write symbols to. The read-write head itself was very simple, and the whole complexity of the machine lay in the pattern of instructions on the instruction tape. The idea of a universal computer may seem obvious today, because we are surrounded by universal machines. It is common knowledge that you do not need to have one type of computer in order to compose an email, another type of computer in order to edit a word processing document, and another type in order to watch a video. The same type of computer can do all those things. However, at the time it was not obvious, and it is fair to say that today's computing industry is based on the ideas of Church and Turing. Computation universality means that computers have an innate capability of interoperating with each other. However, if you look at the modern computing landscape, you will see that this capability seems to be being squandered. It looks as though the Tower of Babel has just come down, and there are multiple incompatible languages and operating environments proliferating on the scene. This represents an enormous waste of resources, since computer programmers have to repeatedly reinvent the wheel. The problem is associated with a number of causal factors. One is the Monopolies and Mergers Commission, whose job it is in life to create a kind of Darwinian natural selection between companies and to prevent them from merging together into larger cooperative organisations. Another cause of the problem is the copyright laws. Copyright laws are designed to prevent the flow of information by assigning ownership to particular pieces of information to individuals or corporations. And lastly, similarly to the copyright laws, there's a proliferation of incompatible licenses which also prevent software from being effectively reused. To give details of the type of incompatibility I am talking about, consider that software often has a kind of layered structure, with upper layers dependent upon lower ones. To give an example of a low layer, a computer programming language would qualify, and software that's written in that language would be considered upper layer and would depend upon the lower layer of the programming language. Another example of a low layer would be a device driver, and again, device drivers have multiple things that depend upon the interface that they provide. There have been a number of attempts to generate portable computer programming environments. C is an example of an early attempt at this. C was relatively successful, but you had to recompile your programs on your target architecture, and also there were issues with endianness and register size and such things, so it wasn't a very effective solution. Smalltalk may have done slightly better in some respects. It introduced the idea of a virtual machine, but unfortunately Smalltalk didn't have any security features, and you had to compile your program into the virtual machine, so Smalltalk wasn't terribly successful either. Java was the next implementation of a virtual machine that had some traction on the desktop. However, again, it wasn't as successful as it could have been. Java should have reduced the operating system to a bunch of device drivers, basically, and that's more or less what it did in the mobile phone arena. However, hasn't made much impact on the desktop programming environment for most people. Nice idea, but unfortunately wasn't very successful. Another attempt that's been made to produce portable programs is the idea of a virtual machine that emulates an entire computer, so a virtual machine inside your current physical machine, including processor emulation and so on. However, this is just unbelievably inelegant, basically. The computer wasn't originally designed to emulate another computer, and it doesn't do it terribly well, and immensely attractive to have multiple copies of operating systems inside a machine, so that's not a very nice solution. Another attempt at portability is the web browser, which is in practice how a lot of portable programs are written these days. However, the web browser is a nightmarish computer programming environment, huge numbers of incompatibilities between various different implementations, just the whole JavaScript DHTML model is a complete mess, basically a nightmarish computer programming environment. So at the moment the situation is quite fragmented. A lot of the existing previous attempts have been failures or have only been of very limited success. The root cause of some of these incompatibility problems is political and legal. However, there are some things that can be done on a technical level, and I'd like to start by looking at the issue of device drivers. So to start with, here's a cybernetic diagram of an organism. Next, here is a corresponding cybernetic diagram of the inside of a computer. And now, a cybernetic diagram of a computer software programming environment. One thing to note here is that these diagrams are relatively simple. There is only one type of input, which consists of a digital stream of information. Similarly, the outputs also consist of digital streams of information. There's stream-based input, packet-based input, and memory-mapped input, and similar paradigms for output. But beyond those, all types of input devices have a very similar structure from the perspective of the computer programming environment. One thing that this suggests is that device drivers could be made a lot simpler than they are today. Often, device drivers are written in machine code and provide an extremely low-level interface to the hardware. However, there's no reason in principle why device drivers couldn't be written in a human-readable and machine-readable text file-related format, which offers a description of the type of input offered by the device and how to interpret the input and output signals that it receives. Such device drivers would be portable. There would be no need to rewrite them for different operating systems. Portable device drivers and the resulting plug-and-play functionality seem like a simple and obvious way to improve existing systems. However, the vendors responsible for today's dominant operating systems are among those least likely to embrace the idea, since having device drivers that are devoted to your own particular brand of operating system is a way of creating lock-in and dependency among your customers. It makes it harder for them to unplug their device, take it to a new operating system and install it, since first of all more device drivers have to be written for that device on the new operating system. So, although the idea seems technically attractive, it seems reasonable to expect political resistance to the idea among existing software vendors. So, enjoy.